Hello students, in this video we are going to discuss solving the LPP problem using graphical method. Let's take one problem using graphical method to solve the following LP problem. So maximization problem is z equal to 2x1 plus 3x2 with conditions x1 plus x2 less than or equal to 30, x1 minus x2 greater than or equal to 30, and third one x1 less than or equal to 20, fourth one x2 less than or equal to 12, and fifth one x2 greater than or equal to 3 with the non-negative constraints x1 comma x2 greater than or equal to 0. So solving this problem, first we have to find points of each line from the given inequalities. So first convert the inequalities, that is constraints, conditions, into equations. So x1 plus x2 less than or equal to 30, converting into equation we get x1 plus x2 equal to 30. So from this equation we have to find 2 points minimum. So we need draw a line for each and every inequality. So for this we have to find 2 points in each and every line. So in this line x1 plus x2 equal to 30, put x1 equal to 0, we get x2 equal to 30. So the point is 0 comma 30. So in a similar manner we have to find another point 30 comma 0. So simply put x1 equal to 0, we have to find x2, and x2 equal to 0, we have to find x1. So in a similar manner we have to find points of another equations one by one. So let us take second inequality x1 minus x2 greater than or equal to 0. Converting into equation we get x1 minus x2 equal to 0, that is x1 equal to x2. So both are equal, that is in general n comma n. So from this general case we get at least 2 points, any 2 points. For example 0 comma 0, 1 comma 1, or 2 comma 2, or 3 comma 3, like that. And then third one x1 less than or equal to 20, converting into equation x1 equal to 20, that is constant line. So x1 equal to 20 for any x2, we get the point 20 comma n. So n is any value. In a similar manner x2 less than or equal to 12, converting into equation x2 equal to 12, we get the point n comma 12, because x2 equal to 12 is a constant line for any points x1, we get n comma 12. So in a similar manner final one x1 greater than or equal to 3, converting into equation x2 equal to 3, that is constant line. So we get the point n comma 3. So x2 equal to 3 is a constant line for any x1, we get n comma 3 generally. Okay, so using these points, first mention the point and then joining the point we get the corresponding line. Okay, so this line is x1 plus x2 equal to 30. So first put the line 0 comma 30 and 30 comma 0. Joining these 2 points we get the line x1 plus x2 equal to 30. So in a similar manner to draw all the lines, x1 minus x2 equal to 0, then x2 equal to 30, x2 equal to 12, x2 equal to 12, then last one x1 equal to 3, this line, x2 equal to 3, sorry, x2 equal to 3, this line. So after drawing these lines we find out the region, boundary region, so using these inequalities. So x1 plus x2 less than or equal to 30, satisfying the region below the line x1 plus x2 equal to 30, and x2 less than or equal to 20, satisfying the region left side of the x2, left side of the x1 equal to 20. So in a similar manner to mention all the regions, next one x2 less than or equal to x2 greater than or equal to 3, x2 greater than or equal to 3, Next, mention the region for the line for the inequality x2 less than or equal to 12. So x2 less than or equal to 12, that is below the line x2 less than or equal to 12. The region of x2 less than or equal to 12 is below the line of x2 equal to 12. Okay, and x1 less than or equal to 20. The region of x1 less than or equal to 20 is left side of the line x1 equal to 20. Another line, another inequality, x1 minus x2 greater than or equal to 0. So the region of x1 minus x2 greater than or equal to 0 is below the line of x1 minus x2 equal to 0. Okay, so in this region satisfies all the points. In this region the inequality satisfies all these points. Okay, so let us check which point is satisfy this inequality, then that side take the region. Okay, okay, so finally it is the common region. It is the common region for all the inequalities. So in this common region the boundary points are a of 0 comma 3, b of 20 comma 3, and c of 20 comma 10, and d of 18 comma 12, and then finally e of 12 comma 12. Okay, so a, this one is b, this one is c, this one is d, and then this one is e. Okay, so at the point e we can solve the lines x1 minus x2 equal to 0 and x2 equal to 12. So solving these two equations we get the point 18 comma 12. So in a similar manner we have to find all the points. So finally let us find the value of z using these points one by one. So at point a we get z equal to 15, at the point b we get z equal to 49, at the point c we get z equal to 70, at the point d we get 72, at the point e we get z equal to 60. So for these values let us choose the maximum one, that is 72. So it is the solution for the given problem, that is the maximum value of z occurs at the extreme point d of 18 comma 12. Therefore the optimum solution is maximize z, maximum z equal to 72 at the point x1 equal to 18 and x2 equal to 12. Okay, so it is the final solution.